Hi, in this problem I'm going to be talking about how to use the intersect feature of our TI-84 graphing calculator, of this guy, in order to solve a word problem. In this particular word problem, we already did a video about the intersect feature, so really the tough part is figuring out what exactly we're going to graph here. And the problem says this: you're designing a marble basin that will hold a fountain for a city park. The sides and the bottom should be 1 foot thick, so you can see that's all labeled here, right? The walls of this basin here are 1 foot thick. It also says the outer length of the basin should be twice its outer width and outer height. You'll notice that they've already given us that with the x's and the 2x here in the picture. So that's pretty nice of them to give the diagram. It says what should the, 8 bells. Hold on. 5, 6, 7, 8. Okay. All right, so it says what should these outer dimensions be of this basin if the inside is supposed to hold 36 cubic feet of water? So really the complicated thing is this. First of all, we're dealing with volumes here, 36 cubic feet, right? And so I know if I'm working with a box shape like this, a rectangular prism, that the volume is equal to length times width times height. And that's easy enough. And it would be very simple for us to say, hey, this should be 2x times x times x. But the problem is the water isn't held by the outside thing. We got to take into mind and account that this is a 1 foot thick wall. So I'm going to redraw a box here, and this box is going to represent then not the outer walls, but the inner walls, where the water is going to be actually be stored within it, right? Now the problem is this. See, this 2x goes from outer wall here to outer wall here. And this thing is, the inner walls are not as wide, right? So the question is, how much am I removing from that 2x? Well, I've got a foot here that I'm going to remove, and I've got a foot over on the right-hand side that I'm going to remove. A foot here and a foot here. 2 feet that I'm going to remove, and that's from the thickness of the wall. So this is no longer 2x, it's 2x minus 2. As far as the width goes, the depth of this object, I have x if I go all the way from front to back on the outer walls, but I've got to remove a foot from the front and a foot from the back. So I've got to remove 2 feet here as well. X minus 2. And then the last one here, as far as the height goes, x is from all the way at the top to all the way at the bottom, but remember, we've got to have something at the bottom to keep that water in. There's a foot of space right here that I have to remove. There's no top on it, so this one is only x minus 1. And honestly, if you can get from here to here, then you're going to be good enough to do this problem. That's by far the hardest part of this problem. 8 more bells, just a second. Okay, 8 bells, class has started, here we go. And, next part, ready? If I know that the volume is length times width times height, and I now know the dimensions of my inner circle, here's what I can do. I can replace the volume with how much they told me it was going to be, 36. I can replace the length, width, and height with my dimensions of my inner box here, which is 2x minus 2, x minus 2, x minus 1. No manipulation. Do not foil this out. Don't try to do anything here because you're just giving yourself a chance to screw up. Just like we did in the last problem. One side is y1. The other side is y2. So let's go graph. y1 is 36. y2 is 2x minus 2, x minus 2, x minus 1. I'm going to graph these. And the problem is whenever I graph it, there's the first line. Here's y2, the curve. Where's the 36? I don't see it anywhere, right? And the problem is of course, I'm only graphing up to 10. If we go to the table, we're going to see it pretty clearly. Look at the y-coordinates I'm dealing with. 36 here, right? So, in fact, check that out. I see the solution already. When x is 4, both of them are equal to each other, right? So that's going to be what we're going to end up finding. But let's go do it the right way, okay? Ready? I'm going to go to my window, and I just need to make sure the y-coordinates that I'm working with, I have 46 showing. So let's just go all the way up to 50. That was for the y max. So there's the 36 line. Here comes the curve. Where do they meet? To find that, I just go second, calc, intersect. I scroll over in the neighborhood of where they meet, and I hit enter, enter, enter. And I'm not interested in the y-coordinate, I'm interested in the x-coordinate. X must have been 4. Now, let's go back and reread the question. It says, what are the outer dimensions of the basin? Well, if this is 4, that means this is 2 times 4, which is 8. this is 4, and this is 4. So my dimensions look like this: 8 feet by 4 feet by 4 feet. Those are the dimensions of the basin if I'm going to have 36 cubic feet of water in the inside. So there you go. There's another problem, and we'll work on a few of these similar to this in class.